Today, question number 6, exercise 12.2. An umbrella is made by stitching 10 triangular pieces of cloth of 2 different colors. Each piece measuring 20 centimeter, 50 and then 50 centimeter. How much cloth of each color is required for the umbrella? So now, umbrella is made by stitching 10 triangular pieces of cloth of 2 different colors. So you just assume that this is the umbrella. Supposing this is the umbrella. So here it will contain 10 triangular pieces. So these are all a triangle. One triangle. So just to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are total 10 triangles. So now made of 2 different colors. So pieces of cloth of 2 different colors. So here there will be 2 different types of colors. Just to assume that this part they are the black and these are the white color. Now you see, so there are 10 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 triangular pieces of cloth of 2 different colors. So the colors will be 2. So that means there will be 5 triangles of means black color and the 5 triangles of means white color. So these are the white color triangles. So 1, 2, 3, 4, 5, one color. Then the next color 1, 2, 3, 4, 5. That means you will have 5 triangles of each color because there were 10 triangles. Now here they have given that the sides of the triangle, each piece. So now each piece looks like a triangle. So they are a triangle. So this is one piece, this is the other piece. So in this way they have made the pieces shape in the form of triangle. So you can take the whole umbrella in this form. So you will get 10 triangular pieces of cloth. So with these 10 triangles they have made the umbrella. So now they are all the triangular pieces. So here we have given each piece measuring 20 centimeter, 50 centimeter and then 50 centimeter. So these are the two 50, 50. So it is given and then this will be 20. Similarly all these will be 50, 50 and this will be 20. So the base will be 20. So these long sides that is going to the vertex. So this will be all 50, 50. So now you are going to find the how much cloth of each color. How much area of cloth of each color will be required for the umbrella. So you are to find the area of cloth used for each color. So that means you are going to find the area of a triangle. You are going to find the area of a triangle because all the triangular areas will be same. Because all these measurements will be like this only. It will be 50, 50 and this will be 20. Again it will be 50 centimeter, this will be 20. So that way you will first find this triangular area using the Heron's formula. Why? Because they have only given the 3 sides of the triangle. As you know that if in a triangle the 3 sides of the triangle are given, then to find its area you are going to use the Heron's formula. So you are going to find out this area and then you will multiply this triangular area by 5. Why? Because you are going to find the area of cloth of each color. You are going to find the area of cloth for one color. So one color has got 5 triangles. So first you will find the area of a triangle multiplied by 5. Then you will get the area of each color. So now first let the sides of a triangular piece B. So B, say you take A. Let us take this side 50. So it is A. This will be B, 50 and the base this will be taken as C. So here A equals to 50 centimeter. Then B also 50 centimeter and C is 20 centimeter. Now you will find S. So S equals to A plus B plus C divided by 2 equals to. So now equals to A. So A is 50 plus 50 plus 20 divided by 2. So by adding, you will get 120 by 2. So on cancelling, you will get 60 centimeter. Now you got this S. So from this, you are going to find the area of one triangle, because by finding this area, you are going to multiply by 5. Why? Because the number of triangles of each color is 5. Because 5 of one color and 5 of the other color. So each being a triangle. So each of the triangular area will be same. So that is why first you will find this area, then multiply by 5, you will get the area of cloth of each color. So now area of triangle. Area of a triangle equals to root over S into S minus A into S minus B into S minus C. So this equals to, now here S equals to, so here S you got 60. So it will be 60, so it is S into S, again it will be 60 minus A. So here A is 50. So A is 50 into S. So you got S 60. So 60 minus B. So B is 50. So you took 50 into S. Again 60. So 60 minus C. So C is 20. Now from this equals to, so the whole root, so it is 60, so 60 into, so 60 minus 50, it will be 10 into 60 minus 50, so it is 10 into 60 minus 20, you will get 40. So this is the square root, so your main aim will be to take the factors in pairs. So here you see 10 into 10, 10 square. And here there is single 0, so here you will get 10 into 4, so you got one 10, 10 into 6, so 10 and 10, you will get 10 square, and this 4 will be 2 square. So now equals to, this will be 60 into 10, so 10 into 6, so 10 into 6, 60, into, so this will be 10 square, so let us make 10 into 10, so 10 into 10. So 10 into 6, 60. 10 into 10 into, so 10 into 4. So you got 40. So equals to, now this 10 into 10. So this 10 and this 10, it will be 10 square. Into 10 into 10, this will be also 10 square. Then this 4 will be 2 square. And this 6 will be just 6, because if you break it also, you will get 2 into 3, so you will not get the power 2. Last, like here you got the square, then will be solved. But here only 6, so it's 2 into 3, so you just write 6 only. So now how you took 10 into 10, 10 square, 10 into 10, 10 square, then this 4 is 2 square and this 6. So now root over 10 square, you will get 10. Root over 10 square, it will be 10. Root over 2 square, it will be 2. Then root 6, because there is no square, so it will be root 6. So you will get 10 into 10, 100. 100 into 2, 200 root 6 centimeters square. So you have got the triangular area of one triangle. That means only for one triangle the total area is this, and all the triangles the areas will be 200 root 6. So all this triangle, each of the triangular area will be 200 root 6 centimeters square. Now they said each piece measuring 20, 50 and then 50 centimeter. How much cloth of each color? So how much cloth? You are to find the area of cloth of each color required for the umbrella. So here containing two different colors. So the number of color is 2. and the total triangle is 10. So 5 of one color and 5 triangles of the other color. So that is why now you are going to multiply by 5 to get the area of cloth for one color. Now, number of triangles of each color equals to 5. So the number of triangles of one color, that means each color you will have 5 triangles, because the total number of triangles is 10. So of 2 different colors. So 5 triangles will be for one color and the remaining 5 triangles will be for the other color. So therefore area of cloth required for one color. So you have 5 triangles. So one triangle is 200 root 6. So 5 triangles, it will be 5 times. So it will be 5 into 200 root 6. So you will get 1000 root 6 centimeters square. Then and area of cloth required for the other color. So other color, because the number of color is 2. So again for the next color you will get the remaining 5 triangles. So 5 into the area of a triangle. So it will be 5 times. So 200 root 6 centimeters square. So you will get 1000 root 6 centimeters square. So this will be your answer. So your answer will be 1000 root 6 centimeters square, then 1000 root 6 centimeters square. So these two will be your answer. So now here, so this is the umbrella containing 10 triangular pieces of cloth made of 2 different colors. So the number of color is 2. So as the number of triangle is 10, so 5 triangles will be for one color and the remaining 5 triangles will be for the other color. So the area of each triangle is the same. So for one triangle you have got the area of a triangle, you got 200 root 6. So each of the triangular area will be 200 root 6 centimeters square. So the area of one color, so you will have 5 triangles. So 5 times into the area of the triangle. So you got the same answer. So 1000 root 6 centimeters square and 1000 root 6 centimeters square. Now it is question number 7. So here they have given a square. So this is the only question so they have given. So the question is long, that is why now I will just tell it. So here this is a kite. So let us name that ABCD is a square shaped kite. ABCD. So here they have given a kite and the base is an isosceles triangle. So this is an isosceles triangle where the sides are given, equal sides are given as 6 and the base is 8 centimeter. And here they have made three settings. So this is the setting 1, that is A, B, C, set 1, and A, B, C. This is set number 2, and this is the set number 3. So they have told to find the area of paper used in each shade. So how much paper is used in this triangle, and how much paper is used in this triangle, and the area of paper used in this triangle. So that means you are going to find separately the area of paper used in each of the sets. So here they have given that ABCD is a square shaped kite. So this is a kite and the shape is a square shaped, with the base of the triangle is an isosceles triangle where the equal sides each measuring 6 cm with the base 8 cm, and the length of the diagonal is given for the square, it is 32. As you know that the diagonals of a square are equal, so it is the property of a square. So here you need to know the property of square. So property of square, what is that? The diagonals of a square are equal. The diagonals of a square are equal, which means AC equals to BD equals to, so the diagonal is given 32, so 32 centimeter. This one is given. So the diagonals of a square are equal. So AC equals to BD. Each of the diagonals will be 32 because the diagonals of a square are equal. Then again, number 2, the diagonals of a square bisect each other at, that means right angles. So here, that means AC is perpendicular to BD and they bisect. So here, number 2, the diagonals of a square bisect. Diagonals of a square bisect each other. So each other at right angles. So now, diagonals of a square bisect each other. That means the two diagonals BD and AC, they will both divide each other into equal halves. That is called bisecting. So here that means the diagonals of a square bisect each other means AO equals to CO, BO equals to DO, and the diagonals bisect at right angles. So here you will get 90 degrees. So the two diagonals will meet at 90 degrees. So this will be 90 here. So these are the two important properties. So you will need to know to solve this question. So here the first one is given as a square shaped kite with the base as an isosceles triangle, and the length of the diagonal of a square is given as 32 centimeter. So from the property we have come to know that the property of a square, diagonals of a square are equal. So each of the two diagonals length will be equal. Each of the diagonals measuring 32. So BD 32, AC 32. And the two diagonals will bisect each other. That means AO equals to CO and BO equals to DO. That is called bisect. Then the two diagonals will bisect at right angles. That means these two diagonals will meet at 90 degrees. So now to get the set 1, as I have told you that though here they have not given the sides, but you can find out how, because in this triangle this is the base, this is the height. So if they have given the base and the height, then to get the area of the triangle you will use half into base into height. So this will be the base and BO will be the height. Similarly for the triangle ADC, this will be the base and this OD will be the height. So now here, so you are asked to find the area of paper used in each set. So for the set 1, for the set 2 and for the set 3. So you will find separately the area of paper used to make the kite in each of the settings. So now let ABCD be a square shaped square kite such that AC equals to BD equals to 32 centimeter, because these are the two diagonals and we know that the diagonals of a square are equal. Then an isosceles triangle, so let us say DEF, so DEF, so it is D, then E and F, and triangle DEF, isosceles triangle DEF, such that with DE equals to DF equals to 6 centimeter. So DE equals to DF, each being 6, with the base EF equals to 8 centimeter. So it is 8 centimeter, 8 centimeter. So now you are asked to find the area of each set. So now we know that diagonals of a square bisect each other at right angles. So this line is very important, because without knowing this we cannot directly tell half into base into height, because the question will be how this is the height. So that is why you have used this. You can say that this is the height only from this property. So we know that the diagonals of a square bisect each other. Each of the two diagonals divides the other diagonal into equal parts, that is called bisect, and the two diagonals will meet at right angles, that means it will be 90 degree. So now therefore here BO equals to DO, so BO equals to DO equals to half of, so BO is half of BD, and DO is also half of BD. So this gives BO equals to DO equals to half into BD. So here BD is given 32, so it is 32. So by cancelling you got 60 centimeter, so it is 16. So these two got 16 and this is 32 AC. Now you are to find the area of triangular set 1. So this triangle, so area of triangle, so ABC, that is set 1 equals, so now as AC and BD they will meet at 90 degrees, so that means this will be the height, and in this triangle ABC, here DO will be the height, and here AC will be the base for the triangle ABC and for the triangle DAC. So for the triangle ABC, so here height is given, so you will use half into base into height. So your base is AC, so AC half into base, so base is AC into the height, so your height is OB. So you got your half into AC is given 32 and here OB you got 60. So OB equals to DO equals to 60. So in place of OB you will put 60. So you on cancelling you will get 256 centimeters square. 16 to 16 you will get 256. Now you will find area of triangle, that is ADC. So you have finished the triangular area for the set 1. Now you are going to find the triangular area for the set 2. So this will be the set 2. So area of triangle, that is DAC. So DAC, that is the set 2. So for set 2 equals to half into base. This is the base and this is the height, and E into DO. So equals to half into, so AC is given 32, so it is 32 into DO is given 60, so DO equals to 60, so it is 60. So on cancelling, you have got 256 centimeter square. So you got the area of set 1 and the set 2. Now you are going to find the area of set 3, that is for this isosceles triangle. So now here in this triangle, they have not given the height, but here you got the height, because according to the property of the square, the diagonals of the square meet at 90 degrees. So this is why this 2 has become the height, and this AC has become the common base for both the triangle. But in the triangle DEF, here they have given the 3 sides of the triangle. That is why you are going to use the Heron's formula only to get its area, because had they given the height, in that case half into base into height, but as there is no height, only the 3 sides of the triangle they have given, so you will use only the Heron's formula. Now, let in triangle DEF, so DEF, so you take the A as 6, so A equals to 6 centimeter, B equals to 6 centimeter, so this is A, this is B, this is C, so equals to 8 centimeter. Now S, so S equals to A plus B plus C divided by 2. So 6 plus 8 divided by 2. So you got 8 plus 6, 14 plus 6, 20 by 2. So you got 10 centimeter. So now, so you are going to find the area of triangle DEF using the Heron's formula, because there is no height. So area of triangle, there is DEF, so DEF, so DEF, that is for the set 3, so equals to now the Heron's, so it will be root over S into S minus A into S minus B into S minus C, so equals to the whole root. So here the S is 10, so here S value is 10, so in place of S 10 into S, so it will be 10 minus A, how much is A? A is 6 into, so S again 10 minus B, so B is 6 into S, so the S is 10 minus C, so C is 8 equals to, so now 10 into, so 10 minus 6, it is 4 into 10 minus 6, 4 into 10 minus 8, it will be 2. So this is a square root, so you will try to take the factors in pairs. So here 4 into 4, 4 square, and this 10 you can make 2 into 5, that 2 into 2, that will be 2 square, and 1 5 will remain. So here equals to, so here 10 you just break it, you will get 2 into 5, this is 10, so this is in pair, so you just put it the same, 4 into 4, and it will be 2. So now 2 into 5, 10, this 4 into 4 kept it same, because you will get 4 square, and this 2. Now 2 into 2, it will be 2 square into 4 into 4, it will be 4 square into, this is 5. Now equals to, now root over 2 square, so you know into root over 4 square, it will be 4, and 5 has got no square, so that will remain within the root, so root 5. So equals to, you got 8 root 5. So 8 root 5 centimeter square. So you can keep it this way also. So you have got the total area, so you have got the area of each of the settings. So these two settings area is the same, and this area you got 8 root 5 centimeter square. So here you have used the Heron's formula, because you know it that as there is no height, so only the 3 sides of the triangle they have given. So in that case you are to use the Heron's formula to find out its area, and in this two, using the property of the square, so you have found that DO and DO, they are the heights, and this AC has been the common base. So you have used in this two half into base into height. So these are the answers. Today we will be doing question number 9. So here they have given that a field is in the shape of a trapezium. A field is in the shape of a trapezium. Whose parallel sides are 25 meter and 10 meter. The non-parallel sides are 14 meter and 30 meter. So find the area of the field. Find the area of the field. Now, field is in the shape of a trapezium whose parallel sides are 25 meter and 10 meter. The non-parallel sides are 14 meter and 30 meter. Find the area of the field. So the field is in the shape of a trapezium. So as you know, the trapezium with only a pair of opposite sides parallel, only one pair of opposite sides you will get parallel. So here let us take that this is a trapezium A, B, C, D. So a quadrilateral with only a pair of opposite sides parallel, you will get only a single pair. That means these two sides AB is parallel to BC, and here AD and BC, they are the non-parallel sides. These two sides cannot be parallel. So now they have given that parallel sides are 25 and then 10 meters. So AD is parallel to DC. So these two lengths they have given 25 and then 10 meter. So this is the longer side. Let us take. So let us take this is 25 meter, and we take the side DC as the 10 meter. So we took it as 10 meter. And the non-parallel sides are 14 and 30 meters. So these two are the non-parallel sides. Let us take this as 14 meter and say this will be as 30 meter, or else 14 and 30. Doesn't matter. You can take 40, 30. Now you have to find the area of the field. So this is the trapezium field. You have to find the area of this whole field. So now, as you know, area of trapezium, because the shape is trapezium. So area of the field, that is this trapezium shaped field, equals to half into height. So you get equals to half into height into sum of the parallel, so sum of the parallel sides. Let us take say L1 and say this is L2. supposing. So these are the two parallel sides. So the formula is given by half into height into sum of the parallel sides. So L1 plus L2. So sum of the parallel sides. So it is L1 plus L2. Now by seeing these two, you have got L1, L2. Because L1 is given 25, L2 is given 10 meter. But there is no height because these two cannot be called the height. Height will be always, they will make 90 degree, perpendicular. That will be. So now as there is no height, so without this height, you cannot get the area of this trapezium shaped field. So for this, what you will do? So there is a way you will make construction. How to do? So through the vertex C, you can draw a line that will be parallel to the side DA. So through the vertex C, we will draw a line that will be parallel to the side DA and that will meet the side AB say at point say E. So here construction. So through C, we will draw a line that will be parallel to DA. That will meet the side AB at say E. So D then E. Now so our main aim will be to find out this height, to get this height. Now these are the two parallel lines. So the distance between the parallel line, distance means the height. So the distance between the parallel, so you draw from here to here 90 degree and you draw from here to here, you will get it same. Why? Because these two lines DC and AB are the parallel lines. So again here, since you need the height, so from the vertex C, we will draw one more altitude. So a perpendicular line is drawn from the vertex C to BE, say at point F. So this is the height. Let us take this as the height. So the distances between the parallel lines, distance means the perpendicular line, that like the CF, they will be same. You draw from CF, C to F, or you draw from here to here at 90 degree, the height will be always same. So you have drawn through C to the base AB at F. Now you need the height because you have got the parallel sides. So it is 25 and then 10. So now what we do is we will make this figure parallelogram. How? Through C you have made CE parallel to AD. So you have made CE parallel to DA. This is true construction. And then DC is parallel to AB. That one is already understood because this is a trapezium. So here DC is parallel to, so DC is parallel to AE because DC is parallel to AB. So AE is just a part of the line segment AB. So now you see in this quadrilateral AECD, you got both the pairs of opposite sides parallel. CE parallel to DA and DC parallel to AE. So both the pairs of opposite sides are parallel. Therefore, AECD is a parallelogram. So as AECD is a parallelogram, so the opposite sides are equal. So this also will be 13 meter. This will be 13 meter. And here AE equals to DC, opposite sides of parallelogram. So it will be equal. So AE will be 10 meter. Then how much will be BE? So from the total 25 minus 10, you will get here 50 meter. 50. Now you see, this is a triangle. You got this side 30 and they have given here 40 and this one you got 50. So by using the Heron's formula, you will get area of triangle CEB. CEB, then again you will use half into base. This will be the base and this will be the height in this triangle CEB. So by equating, you will get CF. That is the height. Once you get the height, then you will get the trapezium, because the two length of the parallel sides are given. One is 25, other is the 10. So now here let ABCD be a trapezium shaped field with AB parallel to DC, with AB parallel to DC. Then through C. So here through C, so through this C, CE parallel to DA. So this line C is drawn parallel to DA. C parallel to DA is drawn to meet or to intersect AB at E. So therefore AECD is a parallelogram. Why? So AECD is a parallelogram because since CE parallel to DA, so CE parallel to DA, so it is given, and then AB is parallel to DC, so AB meets AE, so AE parallel to DC. Now you see, both the pairs of opposite sides are parallel. The two pairs of opposite sides are parallel, therefore AECD is a parallelogram. So the opposite sides of the parallelogram are also equal. So therefore CE equals to DA equals to 30 meter. So you have got this side 30 meter because they are the opposite sides of the parallelogram, and then AE is equal to DC. AE is equal to DC is equal to 10 meter. So you got this one 10 meter. Then how much will be BE? So how much will be BE? So therefore BE equals to, so to get the length of BE, so from the total length of AB minus AE, so from this total length that is 25 minus this AE that is 10, you will get BE. So equals to 25 minus 10, you have got 15 meter. 15. Now you have got in this triangle all the three sides. So you will find the area of this triangle using the Heron's formula. Though there is a height, so in the next step you will find half into base into height. This will be the base and this will be the height. So now let in triangle CEB. So here A, let us take 30. So it is 30 meter. Then B, let us take 15. So it is 15. And then C, let us take the 40 meters. So A, B and C. This is the triangle. So S equals to A plus B plus C divided by 2 is equal to, how much is A? It will be 13 plus B, it is 15, then plus C, 14 divided by 2. So 5 plus 4, 9, 9 plus 3 will be 12. So 1, 2, 3 plus 1, it will be 4. So you have got 21 meter. 20. Now you will find the area of triangle. Area of triangle CEB. So CEB equals to root over, so S into S minus A into S minus B, S minus B into S minus C. So equals to the whole root. So s is 21. So 21 into 21 minus a. So a is 30. So 21 minus b is 50. 21 minus c is 40. So equals to 21 into, so 21 minus 13, you will get 8, into 21 minus 15, you will get 6, into 21 minus 14, it will be 7. Now we will break this factor. So 21, that will be 7 into 3. So 7 into 7, you have got 7 square. So it will be 7 into 3, you got 21. Then this 8, you have got 2 into 2 into 2. So you got 2 into 2, 4, 4 into 2, 8. And the 6, you got 2 into 3. 2 into 3, you got 6. Then into 7. So into 7. So equals to, now 7 into 7, it will be 7 square. Then 3 into 3, it will be 3 square. Then here 2 into 2, it will be 2 square. Then 2 into 2, it will be 2 square. So you got all the factors in pairs. So 7 into 7, 7 square. 3 into 3, 3 square. 2 into 2, it is 2 square. Then this 2 into 2, you got 2 square. So you got here 7 into 3 into 2 into 2. So you have got 2 into 2, 4, 4 into 3, 12, 12 sevens are 84. So you got the area as 84 meters square. 84 meters square. So to get the area of this trapezium, our main aim is to get CF. So that is why you are doing all this. So till we find CF, you are going to do it, because CF is the height of this trapezium. Now again, area of triangle. So area of triangle CEB, by doing you got 84. Area of triangle CEB. So CEB. So this triangle you have got how much? CEB 84. So you got 84 meters square. Now from this triangle again. So in this triangle, this is the base. BE is the base and this is the height. So here half into base into height. So your height is h. Height is h equals to 84. 84. So here half into base. So base is 15. So you got 15 into height. So 84. Now you got 15h. 15 into h, 15h equals to, now you will cross multiply. So 84 into 2. So h equals to 84 into 2 divided by 15. So 3, 5, 3 to the 6, 3, 8. So you got here 56 by 5 meter. 56 by 5 meter. So you got the height. That means now you will get the area of the trapezium, because you need to find the height and you got the height. So 56 by 5 meter. So area of trapezium equals to half into height. This is the height into sum of the parallel sides. So these two are the parallel sides. So AB, sum of the parallel sides. So AB plus DC. So it will be AB plus DC. So now equals to half into height. So height you have got 56 by 5. So 56 by 5 into AB. So AB is 25 plus DC you have got 10. So equals to, it will be 28 by cancelling. So 28 by 5 into 28 by 5 into, you have got 35. 25 plus 10, 35. So 5, 7. So you got 56, 196 meters square. So this is your answer. So what we did here, mainly because of they have not given the height. So to get the height of this trapezium, you have done construction. So through C, you have done this line parallel to the side DA by making AECD as a parallelogram. So because both the pairs of opposite sides are parallel, that is why the opposite sides are equal. So this will be also 30 because the opposite side is 30, and this will be also 10. So to get the length of BE from the total 25 subtract 10, you have got 50. Our main aim is to find this height. So first from this triangle, you have found the area using the Heron's formula. Then for the same triangle, you have used half into base into height, and then you have got the height. Then ultimately you have found out the area of the trapezium. So it's very simple. With this we have completed this chapter. Thank you.